Welcome viewers. In this series of video we are going to discuss about 220 kV double circuit transmission towers structure loadings with IS 802, which is an Indian standard. This is the first stage out of 7. In this we are going to discuss about the electromechanical input required for 220 kV double circuit transmission line towers. So before going to watch this video, we request you to look into our earlier video about modeling of 220 kV double circuit transmission line towers using robot structural analysis. Those videos links are provided in the description. Have a look into that. You can see an Excel sheet on the screen, which is a topic which we are going to discuss in this video. It's an electromechanical input. So first we need the tower profile, voltage level. So there are some list of voltage level which are added here. So we can consider 220 kV because we are already having a 220 kV model which is done in robot structural analysis. The link for those videos also given in the description. Type of tower functions. So either it is a suspension or a small or medium angle tension tower or large angle tension tower, you need to get from the input. So suspension tower means generally the angle of a conductor should be less than 5 degree. Small and medium, it ranges from 5 to 30 degree, the conductor deviation. Small means it is a 5 to 15 degree, and medium it should range from 15 to 30 degree, and for large angle tower the angle of conductor is 30 to 60 degree. This small, medium angle and large angle tower are to be considered as tension towers. So this type of tower and functions you can see in our previous video about the design philosophy of transmission line towers. Those video links also provided in the description. You can have a look before going into this electromechanical input. Next one is a conductor and insulator parameter. So here we can consider a twin conductor. So generally we have a basic idea about this twin conductor or the conductor type which we are going to use for the transmission line towers. If it is in having a 100 plus voltage means or up to from 66 kV, we can consider a single conductor. And if it is a 220 kV, it is better to have a twin conductor. And if it is 400 kV, if it is we can consider a quad or 4 number of conductors. So not only the basic like this, it's also depend upon the conductor span and conductor diameter or conductor type which we are going to use. Say for example, if it is a less diameter or less cross-sectional area, then the stress value or the ultimate strength of the conductor may be less. So that in that case we need to have a quad conductor for 220 kV itself. So likewise there is some methodology we need to fix this. So for our 220 kV structural loads we can consider a twin and ACSR zebra. This conductor type, for example ACSR zebra or ACSR ostrich, there are various type in the name of animals. So these are the type used to followed in Indian standards. If in case of European standard, the type of conductor used to followed in name of birds. So if we are considering the moose, means it is a higher diameter, say for example 31.8, zebra it is 28, for ACSR tiger it is only 16.5 mm. So here you can see in the right hand side tab there is a table which is having the detail about all the ACSR type conductor, having the name of animals and its aluminum area and steel area cross sections. So in this ACSR 131/31 means that 131 is aluminum area and 31 is mean for steel area. So by this is the way we used to designate the conductor types. So after selecting this, so you can see the diameter and the cross section area and the weight of conductor shall be picked from these tables for a reference tab by using VLOOKUP command. Similarly, for if it is a twin, if it is a single, one number of conductor per phase. If it is a twin, it is a 2, and for quad it is a 4 number. So this Excel calculation is prepared in such a way that it should be simplified our input with the tables listed here and the drop down list added in that input selection. So next one is weight of conductor plus a spacer. If it is a twin, we need to provide a spacer, and also for quad. But in case of single, there is no spacer bar is required, only the weight of conductor to be considered, that is 1.63 kg per meter as per this ACSR zebra. In case of double twin, the weight of conductor plus spacer bar is considered for per conductor. It is not considered for two numbers. Only single conductor with its spacer bar for 1 meter length is considered here. Later, while calculating the load, that is a weight of conductor, we can add this twin, that is a 2 numbers per phase. So next one is the span of the conductor, what span we need to consider. So for that we need to refer CBIP manual, that is a Central Board of Irrigation and Power. So in the right hand side you can see the CBIP manual. In that we need to refer the page 121. So these are the design span which are considered according to the voltage level. For 66 kV it should be 240 to 275 meter, and for 110 kV 132 kV it is 315 to 335 meter, and 220 it is 335 to 375. For 400 kV it is 40 meter, and for 800 it is 400 or 450 meter. So likewise this design span to be considered. Also for wind span the definition is given here, and also weighted span in broken wire condition and the normal conditions are given in this. So we are going to consider as per this. So 220 kV it is mentioned as for suspension it is 525 for maximum condition. For minimum it is 200, so we can consider the weighted span a normal condition in the range from 200 to 525. So likewise we need to consider the span. Similar for broken wire condition it is mentioned 100 to 315 meter. So you can see here. So once after selecting this voltage level, you can see the ranges which is as per the CBIP manual is displayed here. So for that we are having a separate table here. according to the CBAP manual class 5.8.3. So this table will extract the range which are showing here for normal design span, wind span, weighted span, normal condition, weighted span, broken wire condition. So what are these spans? Let me discuss about that. See, in the picture which is showing here in the screen, there are 3 transmission line tower which are subject to 3-phase conductor of 2 circuit. So here in this illustration purpose, we got shown only the single circuit conductors. So there are 3 phases. So if you are considering half of the either side of the span of the conductor, that should be the wind span. So wind span should be 2 into half of the design span. Design span is nothing but the distance between the 2 towers. It is a average square root of the 2 span between the adjacent sides. So there is a formula is there. In order to arrive the design span equal to root of squares of this L1, that is the first span, and squares of this second span. So that will give you the design span. In that design span, half of both the side, if you are considering, is the wind span. So wind span is exactly lying in between the center to center distance of the conductor. So half of that. Similar like for weight span, we need to consider the exactly that down, that is a datum line of the conductor in both the side. See, for example, in the left hand side, the conductor span is exactly in line with the middle of the conductor. The sag level, that is a bottom lowest level of the conductor, is exactly at the mid, because these 2 towers are laying in a same plane. But in the right hand side tower, which is just above the middle tower, so that the conductor will go like this, whereas the lowest point of the conductor is close nearest to the middle tower, which is at the lower level, whereas in the higher level, the lowest point of the conductor due to the sag is far away from the right hand side tower. So we need to consider this lowest point, that is a tangent with respect to the horizontal line, only we need to consider as a weighted span. So as these 2 towers are lying in a same plane, exactly that middle of the conductor, the midpoint of the conductor will occur only at the lowest point of the conductor will occur only in the midspan. But in this case where there is a 2 level of transmission line tower, in that the tangent line which is showing is the exact lowest point of the conductor in line with the horizontal line. So these are the distance we need to consider as a weighted span for a normal condition. And coming to the weighted span of broken condition, suppose one side of the conductor is broken due to its failure of material, because this is possible whenever the conductor is attained due to the load, its this ultimate strength, so that breaking of the conductor is possible. So in that case, the conductor will shrink to its span. See, for example, if it is broken at this area, definitely this conductor will shrink to certain level. So that point only we need to consider while doing the load calculation for broken wire condition. So that self-weight of the conductor we need to consider only as per the broken wire span. So this is a fundamental in the calculating of various span, like design span, wind span, weighted span, normal condition, and weighted span, broken conditions. So there are certain regulations and range of dimensions of conductor are given in this CPAP manual. So we can pick it up from here, and according to the project conditions of the transmission line tower locations, this value will vary. So we are considering for our demonstration purpose 350 meter as a design span, and wind span will be the 2 into half of this design span, so that the same value also is 350. And for weighted span we are considering 300 meter, which is in the range of 200 to 525 as per the CPAP manual. So similar like for broken wire condition of weighted span also we are considering the least of this mentioning in that CPAP manual, because of our critical load condition we are going to consider here. So this range is from 100 to 315 meter. So next one is we need to find out the input for tension or suspension insulator details. So here the tension insulators will not applicable if the suspension tower or we are designing. So if suppose this is small, for tension towers we need to provide whether the suspension insulator is required or not. If it is no, then only the tension insulator will be considered. So our case it is only the suspension tower, so the suspension insulator is must in this consideration. So for the size and the diameter and the spacing of the insulators in insulator disc, we can refer the CPAP manual. So page number 119 to be referred. So here in the right hand side PDF file you can see, based upon the voltage level and the insulator type, either it is I single I or V strand, V string, and a tension tower or suspension tower, various classification of insulators. Based upon that, the size and the number and the spacing between the insulator disc are provided in this table. So for us it is a 400 kV, sorry, it is a 220 kV. So 220 kV insulator we are going to design a double circuit, sorry, it is a twin type of conductor. So for double suspension string it is mentioned as 255 as a diameter and 145 is a spacing. So here you can see in the left hand side Excel sheet 250 by 145, and similar like the number of discs per insulator also given in the CPAP manual in that table, showing number of standard disc is 2 into 14. So here 2 into 14 is considered. So if suppose we are going to design 400 kV, then the disc diameter should be 280. So it is given here, you can see here it is 280. For twin it is 280 or 255. Also for single it should be 1. So 220 kV twin we are considering. So these are listed in this table. So you can see here number of discs, diameter of disc, spacing, and the number of discs. So these are listed in this table as per the CPAP manual. So according to the voltage level and the type of tower, this dimension will directly taken from this table. And the length of hardware is depends upon the manufacturer requirement. We can consider this as 970 mm, and the total length of insulator is 14 into the spacing 145, and weight of disc we can consider as a 9 kg. This will vary according to the materials, because the insulator is various type. Insulator is in having a various material categories, like post insulator in the make of uh, the porcelain clay material, or sometimes it is like a polymer or a glass polymer, glass fiber. So there are a lot of materials in terms of insulators. So according to that supplier or manufacturer catalog, we can get this value. We can consider as a 9 kg. And for fixing this conduct insulators, there is a hardware. So that hardware we can consider as a 70 kg. Hardware or these accessories we can call it as. And suspension insulator, yes, of course it is a suspension tower. Suspension insulator is required. We can select as yes. And the number of tension insulator. So in this case, number of tension insulator is not applicable, because we are designing only the suspension tower. And number of suspension insulators we are providing here as one number. Next, we need to provide earthware details. The type of earthware which we had selected is galvanized steel 7 bar 315. So you can see in this table. So accordingly, the diameter of the earth wire, cross-sectional area, and the unit weight are taken from these tables in the right-hand side tab. So number of earth wires per peak point at this top, we are going to connect is 2 numbers. Due to these are the vertical load due to earth wire. So weight span under normal condition. So just we are multiplying the weight per meter into this span, weighted span for normal and broken wire conditions. And a number of wires also we are multiplying here, and we are getting this. For calculating the vertical load due to conductor, we can do it in the load calculations in detail later. Then for tower structure dimensions, we can get this information from our earlier videos in modeling of 220 kV double circuit transmission line tower in robot structural analysis. In that top cross arm fixing height from ground level is 28 meter. So from this node point to this blue color conductor fixing, this is a top cross arm. Up to here it is 28 meter, and from the peak height from bottom of top cross arm, so this height, the blue color conductor fixing point to the earth wire fixing point in the peak, or the height which is mentioned as 4 meter. Adding this to it is 32 meter, which is a total height excluding spike rod if any. So total height of the structure is 32 meter, and the effective conductor span we are calculating by deducting these tension insulators. So in this case we are designing only the suspension tower, so there is no tension conductor, so the value is 0 here. If suppose we are going to design this as a tension tower, large angle tower, so then the tension insulator is applicable. So this length is 3 meter, which we had calculated here. Yes, it is here, and it is a 2 numbers as we had selected as a twin. So it is a 2 numbers of suspension insulator used to come here. So then the number of tension insulator will be 2 here, and the same length of the tension insulator and the number of this number is nothing but it is a two-side this tension insulator used to connect in a tower. You can see here, if we are going to design this tower, middle tower, then the insulator, tension insulator in one side and in the other side we need to detect. So that is what this number 2 is. So accordingly, this from the wind span and weighted span, a normal condition and broken condition, we need to deduct this length of the tension insulator and the two numbers. So, but in case this tower which we are going to do the design is in a suspension tower means, then there won't be any tension insulators and there is no need of detecting the length with the insulator. So that's all about the input data we record for this 220 kV double circuit transmission line tower design using Indian standard IS 802. Later we will discuss about the wind load and other climatic loads. After that we can also discuss about the sag tension calculation and classification of various loads in that transmission line tower and how this load combination we need to apply on that. So all this information we will be seeing in upcoming videos. Thank you for watching. Look at description for more related video. Subscribe to this channel for more updates. Thank you.